Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise. Here for this week's Embedded Executive podcast. This week, my embedded executive is Mike Householder, the Vice President of Business Development at xMEMS Labs. How you doing, Mike?
Good, Rich. Thanks for having me.
My pleasure. So we met just fairly recently at CES, and I was pretty impressed by your technology, and I have to say, I don't impress very easily. So I'd like to talk about what you guys do. Let's back up to the beginning, though. xMEMS, how long you guys been around?
So we were incorporated in 2018.
Okay, that's
and
pretty long,
launched
but first product was when?
launched our first product in 2020.
Okay, so you guys sat around for almost 3 years doing nothing, right?
Well, the whole COVID thing, and
That's true. Good time to launch a company, right?
supporting customers remotely, which we did our best, but now rubber's hitting the road, and things are moving.
Okay, so as the name implies, MEMS-based products, specifically speakers, right?
That's correct.
Okay, I'm very familiar with how MEMS work. And I'm actually pretty familiar with MEMS microphones because they're fairly common, but MEMS speakers, at least to my knowledge, are not as common. Is that true, and why?
Yeah, very true. I mean, MEMS has been around for decades, but it's kind of had a great run in the early to 2010s with sensors. So you've got accelerometers, you've got gyroscopes, MEMS microphones, as you mentioned. Really, MEMS has really been focused around sensing. But there's been some materials innovations over the past several years that have now, kind of brought focus on MEMS as a transduction and as an actuation technology, and that's obviously what would be needed to use MEMS to apply to a speaker.
Okay, when you say materials change, what was it? What is it?
Yeah, so piezo materials have been around for decades, mostly in bulk form, but really the innovation to get it into a small solid state semiconductor is the creation of thin film piezo materials, and that started to evolve roughly around 2015. So now you could basically deploy a thin film piezo material as a layer in a semiconductor process and build that actuation natively into the chip.
So with traditional speakers, size and weight always mattered. When you picked up a speaker, you could tell the quality of the speaker by how heavy it was. But I assume that that's not the case with a MEMS speaker. So how did these things actually work?
Sure. So yeah, I mean what we've been listening to our entire lives has been the conventional coil and magnet speaker. So you've got a copper coil wrapped around a magnet, suspension framing, and paper plastic diaphragm. That's pretty much all our ears have ever listened to. But as with other technologies, the MEMS sensors that we have mentioned, data storage moving from hard drive to solid state drive, there is a natural, I guess, gravitational pull towards a solid state alternative to a mechanical technology, and the speaker has been one of the holdouts, mainly due to the fact that it's a transducer, and really needed the material science advances that we mentioned to actually produce it. So first of all, if we break down the conventional speaker, the actuation occurs from a coil and a magnet. So you run a current through a copper coil to create a magnetic field. You create motion that moves the diaphragm up and down. So the first thing to replace is the actuation. So the thin film piezo material replaces the coil and magnet. So the material property of the piezoelectric effect, you apply a voltage, not a current, but you apply a voltage to the piezo materials. The material property of that piezo will bend when you apply a voltage. So that's your up and down. Simplistically, that's your up and down.
Okay, I was actually just going to ask that question. I mean, it's literally, I mean, the way that I understand MEMS, it's like a what's the word I'm looking for? a bar that literally moves up and down, and it's that action that causes the sound.
Yeah. So instead of instead of using using capacitive sensing to detect motion, so to speak, where we actually have to put something into motion, we have to move air in order to generate sound. So, and that that movement has to be fairly intense and sophisticated to generate high quality sound. So that piezo material is critical to getting the displacement you need and the speed you need to properly move air and generate really high quality audio.
Can you operate at the higher frequencies needed for some of these intense sounds?
Oh yeah, I mean the piezo materials actually like to move fast, and that's one of their benefits. If you look at the standard audio spectrum that a human can hear, 20 hertz to 20 kilohertz, these speakers will produce sound in the ultrasonic region, so well north of 20 kilohertz.
And is it one sensor per speaker, or is it lots of sensors per speaker?
Well, it's basically you're creating, and there's many ways to design this, but you're essentially creating flaps or structures that can move up and down. So whether
Hmm.
it's one big flap or an array of flaps, there's multiple ways to do that.
Is that a technical term? The big flap?
Yeah, highly scientific term.
Very good. The power levels that are required for this, how does that compare with what we're used to?
Well, it's a different beast. These are piezo. It's a voltage driven, not a current driven technology. So the piezo does require higher voltage to drive. We can drive a 94 dB signal in your ear, which is probably louder than you should be listening anyway for extended periods of time. We can drive a 94 dB signal at probably roughly around 3 to 4 volts peak to peak. Um, but these speakers can be driven at a max. Everyone's technology varies, but ours can drive up to 30-volt peak to peak. Um, you're
Wow.
not going to be listening in that range very often, but that's the capability of the technology.
And the anticipated application, is this an earbud type thing?
Yeah, so the current generation, these early generation of MEMS speakers are really focused on things that are in ear or near ear. Obviously, with the goal to advance the technology to get into free air loudspeakers. That's a bigger challenge, but you start humbly in the easy to tackle spaces, and you move out from there.
Do you have those larger speakers operating in the lab? I never even envisioned that.
Yeah, so I mean, without getting into specifics, we did actually announce a new type of speaker recently back in November that's more of a sound from ultrasound principle. So whereas the first generation of MEMS speakers, although they're unconventional in how they move air and generate sound through a piezo actuation, they're still pushing air to
Mhm.
generate sound. Um, this new generation of ultrasonic speaker is no longer using push air transduction. They're using ultrasonic amplitude modulation and demodulation techniques to generate air pressure to generate sound, and that has advantages in terms of producing low frequency, increased levels of low frequency energy, both in ear and in free air. So the path towards a free air MEMS speaker is not going to be conventional transduction because the chip would just have to be too big
Mhm.
and probably cost prohibitive to do so. So you need a new transduction mechanism that does not depend on size and does not depend on displacement for the generation of low frequency energy.
Okay. So in the actual design, what would be on the board? It sounds like you need some power components, and the sensor itself.
Yeah, our transducers they're all solid state. So we talked about the transduction, which is piezo. We took an approach to make this monolithic silicon. So the speaker diaphragm is also silicon. So it's a monolithic silicon implementation. That is the transducer. And yes, because it is driven unconventionally versus a current driven legacy speaker, we do require a custom amplifier and controller chip. So we roll that on our own as well. So it's a 2-chip solution, transducer and amplifier slash driver IC
Okay.
for the total. Yeah.
Are you in any shipping products yet?
Yes, we are. So had a slew of announcements towards the end of 2023. Creative Creative Labs, a well-known name in audio for a long time. They launched 2 true wireless stereo earbud products, the Arvana Ace and Ace 2. Those launched in December, and then those were followed by 3 launches from a hi-fi audio company out of Texas called Noble Audio. So they launched 2 true wireless stereo earbud products and a USB-C wired earbud product with our technology in it. There's also some high-end in-ear monitors out on the market for the true audiophile. These are $1,000 products for the true audiophile who really just wants the best quality sound. So those are also in the market.
Awesome. Thank you very much. This has been pretty enlightening.
Great. Thank you, Rich. Appreciate the time.
That was Mike Householder, the Vice President of Business Development at xMEMS Labs, and I am Rich Nass with Open Systems Media.